In this video, we want to simplify the following fraction without using a calculator. So this type of question is normally quite overwhelming, but we are going to do it step by step, and you would see it's actually quite manageable. Now, as in previous videos, what I'm doing now is I'm quickly drawing myself a cast diagram. This is my little cheat sheet that I use to help me answer these types of questions. So from the cast diagram, we know that all ratios are positive in the first quadrant. We have sine positive in the second quadrant, tan in the third, and cosine in the fourth. And hopefully by now you have dealt with reduction formulas. So we have the second quadrant as 180 minus theta. The third quadrant is 180 plus theta. The fourth quadrant is 360 minus theta or negative theta. And in the first quadrant, we can have theta or 360 degrees plus theta. You also would have learned about cofunctions, that is 90 minus theta and 90 plus theta. So remember, with cofunctions of 90 minus and 90 plus, that sine would change into cosine and cosine would change into sine. And we are going to use these reduction formulae to rewrite all of these ratios into acute angles, because that's the purpose of reduction formula, is to rewrite angle sizes so that it will all be in the first quadrant. So now that we have our little cheat sheet, let us start with the sine of 210 degrees. So sine of 210 degrees places us somewhere in quadrant 3 because it's more than 180 degrees but less than 270. So we are going to use 180 plus theta to rewrite 210. So that will become the sine of 180 degrees plus 30 degrees. And notice that this still adds up to 210. Next, we have the cosine of 150 degrees. So that places me in quadrant 2 because it's more than 90 but less than 180. So for quadrant 2, we'll rewrite 150 as 180 minus an angle. So it will be the cosine of 180 degrees minus 30 degrees. And notice that is still 150 degrees. Next, we have tan of 25 degrees. Now that's already an acute angle, so we don't have to rewrite tan at all. In our denominator, we have tan of 205 degrees, and again, that places us in the third quadrant because it's more than 180 but less than 270. So I'll rewrite 205 as 180 degrees plus 25, which will give me 205. So that is tan of 180 plus 25. Next, in the denominator, we have cos of 315. Now, 315 degrees is somewhere in the fourth quadrant because it's more than 270 but less than 360. So we are going to rewrite 315 as 360 minus 45 degrees. And again, 360 minus 45 is equal to 315. And lastly, we'll use 180 minus theta. So that'll be sine of 180 degrees minus 45 degrees, which is still equal to 135. Now you would notice that for the second quadrant of 180 minus 30 and 180 minus 45, I decided to use 180 minus theta and I steered clear of 90 plus theta. The reason why is because there's a possible sign change when I use 90 plus theta, and also I don't want to unnecessarily change sine to cosine. I first want to see if I can use these reductions and keep the ratios as cosine and sine. So now that we have rewritten each trig ratio, let's deal with them one by one again. So the sine of 180 plus theta is in the third quadrant, and we know that sine is negative in the third quadrant. So that will become negative sine of 30 degrees. Next, we have the cosine of 180 minus 30, which was in the second quadrant, and cosine is negative in the second quadrant. Notice that I'm using brackets now, because if I don't have the brackets, it will read as negative sine 30 minus cos 30. And we are not subtracting them from one another, we are actually multiplying them with each other. So that's why it's important to include brackets in this calculation. Then we have the tan of 25, which was simply the tan of 25. In the denominator, the tan of 205 is tan of 180 plus 25, which is in the third quadrant. And that reduces to positive tan of 25 degrees. And what I immediately notice is that these tan ratios would cancel one another out. Going on in the denominator, cos of 360 minus 45 is in the fourth quadrant, and cosine is positive, so it will be cos of 45 degrees. And lastly, we have the sine of 180 minus 45 degrees, which is in the second quadrant, and sine is positive in the second quadrant. So this will be the sine of 45 degrees. Now the original question said, simplify this without the use of a calculator. That means that you would need to use the special triangles. So for the 30-60 triangle, we have the hypotenuse as 2, opposite of 30 is 1, and the adjacent to 30 is root 3. For the 45-degree triangle, the sides are 1, and the hypotenuse is square root of 2. So if I use these triangles, the sine of negative 30 would become equal to negative of 1/2, because the sine of 30 degrees is the opposite divided by the hypotenuse. Negative cos of 30 would be equal to negative root 3 over 2, because that is the adjacent over the hypotenuse. The tan of 25 already cancelled out. So in our denominator, we have the cosine of 45 degrees, which is 1 over root 2, times the sine of 45 degrees, which is also 1 over root 2. So we have reduced the original angles into ratios or fractions. So now let us simplify these fractions. We'll have negative 1/2 times negative root 3 over 2, which is positive root 3 over 4. And we are going to divide that by, so instead of writing a fraction, I'm replacing that with the division sign. And now if I multiply out, in the denominator I have 1 times 1, which is 1 over 2, because root 2 times root 2 would simply become 2. Now if I tip in times, I have root 3 over 4 times 2 over 1. And that simplifies to 2 root 3 over 4. And 2 divided by 4 is 1/2, so that's root 3 over 2. So my final answer is the square root of 3 over 2.